All right, we are ready to go now. All right, so measures of position 11.5. By the time we get done with this section, hopefully we can compute the percentile rank for a data value. And we can actually find a data value that corresponds to a certain percentile rank within a data set. And the nice thing about percentiles is we can compare values from other data sets, from different data sets. And so we can level the playing field, per se, when we compute percentiles to see which person maybe scored better on a respective exam for a different class or a different school or institution or something like that. Also, we're going to compute three values, which will separate a data set into four equal intervals. They are called quartile values. One of them we've already computed, namely the median. The median happens to be the second quartile of a data set. We'll show you how to find the other two. And then we'll use those quartile values to actually build a box plot for a data set. And box plots can be built manually, and they can also be built using a TI-84 calculator, but we don't have necessarily access to that, so don't worry about that. They're easy enough to build manually when your data set's small, and we'll keep the data set small. All right, so these are the objectives for the section. First of all, let's begin by defining what a percentile is. What is a percentile of a data set? Well, a percentile, or a percentile rank of a data value, indicates the percent of data values in a data set that are less than the particular data value of interest. Okay. So let me give an example. Suppose you take like an SAT entrance exam for a college or a university, or maybe an ACT exam. Suppose you score like in the 99th percentile. Is that a good score or a poor score? Anybody want to take a guess? 99th percentile.
A poor score?
Okay, you're saying it's a poor score. All right. Does anybody beg to differ? If you score 99%,
a good score.
A good score. All right, now, if you score in the 99th percentile, or let's say your score on the exam is the 99th percentile, you know what that means? That means, ladies and gentlemen, that 99% of the other scores on that exam are lower than your score. That means only 1% of the exam scores are higher than your score. You score in the 99th percentile, you're way up there. Do you agree? Now, if you score in, let's say, the 20th percentile, let's say your exam score is the 20th percentile of all the scores on a particular exam, is that a good score or a bad score? Well, 20th percentile is a very poor score, because that means only 20% of the other scores are lower than your score, and 80% of the scores are higher than your score. So that's not a good score. Okay. So percentile means, okay, the percent of data values that are less than your data value, if your data value is like the pth percentile. All right. All right. Now, how do we find these percentiles here? Well, suppose you score 77 on a test in a class of 10 people. So it's a small class, only has 10 students. You score 77. Out of 10 scores, your score is a 77. What is our percentile of our score? In other words, what's the percentile rank of 77? And these are all the scores for that particular assessment in that class with 10 students. Now, you don't have to, rank order your data or order your data to appreciate what a percentile is saying, but to find a percentile value, it's imperative that you do order your data set. So let's order this data from smallest to largest, left to right. And when we do so, we will then have our data ranging from 52 up to 98. So the highest score on this exam was 98. The lowest score was 52. That's quite a range there. All right, anyways, we scored 77. Here's our score right here. So what percentile rank does this score of 77 have? Well, of the 10 scores, how many scores are less than 77? Well, there's 1, 2, 3, and what, 4. So 4 out of 10 is what? 40%. And therefore, 40% of the scores are less than your score of 77. Therefore, 77 must be the what percentile? It must be the 40th percentile. Does that make sense, or what we just did?
Yes.
Okay, so we understand why 77 is the 40th percentile. Because 40% of the grades are lower than our grade and 60% of the grades are higher than our grade. Okay, so does that make sense so far, what a percentile is here? All right. Okay, now, to find the percentile rank for a given data point in a data set with n total values can be easily computed by using this simple formula. So the percentile rank of data value X is going to be equal to the number of data values that are less than X divided by the total number of data values in the data set, N. Then you just multiply that ratio by 100 and attach the percent symbol. And ladies and gentlemen, you then have the percentile rank of data value X in the data set. And notice they're saying that the data value no, they're saying the percentile value, excuse me, should always be rounded to the nearest whole percent. Okay, the nearest whole percent. So like if you got like 89.3% for a percentile, you might want to round it down to 89%. If you got like 89.7 percentile, maybe round it up to 90%. Okay. So what happens if you get 89.5 percentile? Where do we round it? 89.5 percentile. Well, they're not specifying where to round such a result as that, whether we round up or round down. It's not going to make a huge difference whether you round down or up in that case, ladies and gentlemen. I don't think you'll have that problem on Alex, where you're splitting hairs like that. If you get like a percentile rank of like 65.5, should you call it 65% or call it 66%? I don't think you'll have that problem on Alex. If you do, bring it to my attention if your problem's marked wrong, and I'll go take a look at it. And in all likelihood, give you back your point or points there. Okay. All right, now example 2, finding the data value corresponding to a given percentile. All right, now see before, we were given the data value and we wanted to compute the percentile rank of it. But now we're working backwards. Given a percentile rank, what would be the data value? Okay. Now, the number of words in each of the last 10 presidential inaugural addresses is listed below. Find the link that corresponds to the 30th percentile. So these are the number of words that were used in various inaugural addresses, I guess the last 10. From what year, I have no idea. I don't know how dated this is. But so one inaugural address had 2,552 words in it. Another one had only 1,592 words in it. Okay. So of these 10 inaugural address links, if you will, we need to find the length that corresponds to the 30th percentile. In order to do that, we need to order this data, okay? And so therefore, we do order the data from smallest to largest, left to right. And then, ladies and gentlemen, the 30th percentile, keep in mind, is a data value below of which lies 30% of the other observations. So there are 10, notice 10 data values in this data set. And what's 30% of 10? 30% of 10. That's gonna be 0.30 times what, 10, correct? And 30% of 10, which is 0.30 times 10, is gonna be 3. All right, so we need to find the data value below of which lies 3 of these observations. Well, here you go. There's 1, there's 2, there's 3. 3 observations lie below 2071. So therefore, ladies and gentlemen, we would say 2071 is the 30th what of this data set? It is the 30th percentile. Does that make sense how we found the 30th percentile of this data set here? So 2071 is the 30th percentile of this data set because 30% of the observations, which in this case is 3 out of 10 observations, lie below that value. And 70% of your observations are above that value. That's why that's called the 30th percentile. Are we clear on how we found that there for that data set?
Yes.
Okay, so hopefully this is somewhat clear. Here's another example. Suppose 2 students are competing for 1 remaining spot in a law school class. Miguel ranked 51st in a graduating class of 1,700, while Dustin ranked 27th in a class of 540. Now, it seems, ladies and gentlemen, our first impression is to say, well, Miguel was ranked lower than Dustin. So Dustin wins. Agree? Dustin gets that last seat in law school. Well, hold on a second here. You got to understand that these students came from different institutions with different class sizes. You see that? We need to take that into account. So let's not be, rash in our decision here and, automatically say, well, 51 is lower rank than 27th. So, Dustin wins. No, what we got to do is we got to level the playing field here. We need to find the percentile rank for Miguel and Dustin, and then we'll compare their percentile ranks to see who did, relatively speaking, do better. Okay. All right, so here we go. So how do we find what percentile, Miguel's ranking is and Dustin's ranking is here? Well, let's work on Miguel's ranking here first. He ranked 51st out of 1,700 students. So that means, what does that mean, ladies and gentlemen? 51st. Now, be careful. 51st is not a percentile. This means that Miguel's rank was 51st out of 1,700 students. And so therefore, there must have been 1,700 minus 51 or 1,649 students that ranked below him. Does that make sense? If he ranked, okay, from a ranking list, rank number 1, rank number 2, rank number 3, rank number 4, he was 51 down on the list of 1,700 students. Well, that means that 1,649 students must have ranked below him. So now we can compute his percentile. His percentile rank, therefore, is the number of students that were ranked below him divided by the total student body, which is 1,700. And then you discover that Miguel's percentile rank is 97%. So his rank is the 97th percentile for his class. On the other hand, Dustin's rank was 27 out of 540 students. So that means 540 minus 27 or 513 students ranked below him. So Dustin's percentile rank would be 513 students that were below him divided by the total number of students in his class times 90 times 100%.
If it's still going on, it was on the, just straight down this hallway at the other end of student life, across from the alcove area with all the tests.
I'm sorry, what was that again?
Sorry, someone came in and asked a question that wasn't on me.
All right, did you have a question or what? Or were you referring to something else?
Nope, no questions.
Okay, all right, I'm not sure. Okay, so ladies and gentlemen, we can see here that Dustin's percentile is actually lower, not by much, but it is a little lower than Miguel's, percentile rank. So it looks like Miguel here has a slightly higher percentile rank, and therefore Miguel would probably be awarded that last seat in that law school class. Okay. Does that make sense how we leveled the playing field by looking at the percentile ranks as opposed to the relative ranks? Okay. There's a big difference there, right? Because the class size has a bearing on determining the ultimate percentile rank here. So you got to take that into consideration. So it's nice to know we can level the playing field here and get an accurate, differential view as to how these students differ from each other or compare to each other. All right, quartile value. Now, there are 3 quartile values that will take a data set and partition it up into 4 equal size intervals. And these quartile values, ladies and gentlemen, are the first quartile, denoted as uppercase Q sub 1, the second quartile value, Q sub 2, and the third quartile value, Q sub 3. These 3 statistics partition our data set up into 4 equal intervals here. This interval contains 25% of our observations. This interval contains 25% of our observations. This interval also 25% of our observations. And also this last one. Now, because of that, our first quartile is often referred to the what percentile? Anybody want to take a guess? What percentile is this first quartile? What's the percentile rank of the first quartile? Well,
25th.
Yeah, 25th. Yeah, because 25% of the data lies below it. So the first quartile is aptly called the 25th percentile. 25th percentile value. Okay. Below the second quartile lies 50% of your observations. So therefore, the second quartile is often called the 50th percentile. You know, the second quartile also has another name. Not only is it the 50th percentile, but it's often called your median of your data set. It's the median. It's the middle value. And we showed ourselves how to find the median last week. The third quartile, Q sub 3, has 75% of the observations below it. Therefore, it is called the 75th percentile of a data set. All right. The middle 50% of our data, that lies between Q1 and Q2, is called the interquartile range of your data set. IQR, short for interquartile range of a data set. And the IQR value of a data set, the interquartile range, can always be computed by taking the third quartile and subtracting off the first quartile. That gives you the interquartile range, or the middle 50% of your data set. Okay. So these quartiles, these 3 quartiles partition our data set up into 4 equal intervals. That's why they're called quartiles, because quarter means 1/4, correct? 1/4. All right, any questions about that here? All right, and by the way, this would be your minimum. This would be your minimum data point observation down here, and this would be your what? Your maximum data point observation, your data set up here. Together, the minimum, the maximum, and the 3 quartile values is called the 5-number summary of a data set. It's called the 5-number summary of a data set. And it's nice to have the 5 number summary of a data set, because from that information, you can ascertain quite a bit of information. And we'll show you when we cast this in the form of a graph called a box plot, what that can tell us. Okay, so stay tuned on that one. All right, so these are the 3 quartile values, and we're going to show ourselves how to find these 3 quartile values for a data set. This is just reemphasizing the fact that for Q1, Q2, Q3 are the 25th, 50th, and 75th percentiles, respectively. All right, here we have a data set. The data below represents the percentages of total electricity generated that comes from nuclear power for the nations with the 12 largest economies in the world. Listed by size of economy, find the quartiles and describe what they mean. The data is the percentages of total electricity, generated globally, I would imagine, that comes from nuclear power for the nations with the 12 largest economies. So there's 12 observations in this data set representing the 12 largest economic countries in the world, I guess. And this is the percentage of the total nuclear power that comes from that particular country. So in other words, one country generated 76.9% of the global nuclear power. Another country generated only 2.4% of the total nuclear energy generated globally. And a couple of countries here generated 0%. So apparently they had other means for producing power, maybe hydroelectric or wind power or solar power, things like that, or fossil fuel, burning coal at a power plant instead of nuclear power. All right. So do we understand what these numbers represent? All right. Now we want to try to find the quartiles of this data set. So we need to order this data. You must sort it. So now the data has been ordered from smallest to largest, left to right. And the first value we like to compute is the median, because the median splits the data in half. So notice there are an even number of observations in this data set. Being the case, the second quartile or the 50th percentile or the median will be the average of the middle 2 data values in this data set. And so what are the middle 2 data values in this data set? Well, they're going to be right here, because you got 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, 5 observations to the right. So the median is going to be literally the average of the 2 middle data values in this data set. Your median turns out to be 9.75. That's your 50th percentile. So that's Q2 right there. All right. So second quartile is 9.75% of the global nuclear power generated. Okay. That's the second quartile. Now, how do you think we're going to find, the first quartile? Well, the first quartile then is going to be the median, if you will, of the lower half of the data, the middle value of this lower half. And what would that be there? Well, what is the average of the 2 middle values in the lower half? The average of 0 and 2.4. That's going to be your first quartile. So your first quartile is going to be the average of 0 and 2.4. So you just add these up, divide by 2, and you get the first quartile, which is 1.2. 1.2%. That's your first quartile of your data set right there. That's your 25th percentile. Now, to get the third quartile, that's going to be the median of the upper half of your data. That is going to be the, what would it be here? 1, 2, 3, 4, 5. 2, 3, 4, 5. 2. 1, 2. Oh, okay. Hold on a second here. Wait a minute here. I don't have this right. The second quartile lies dead center between 3.7 and 15.8. So the lower half of your data set, ladies and gentlemen, is going to be 3.7 on down to 0. That's what it is. And so the first quartile is the median of or the average of 0 and 2.4, which indicates that 2 observations are below that value. Or you could say technically 3 observations are below Q1 and 3 observations are above Q1. All right, now Q3, that's going to be the median of the upper half of your data. And there's 1, 2, 3, 4, 5 observations in the upper half. No, not 5 observations. There's 6 because Q2 is dead center between 3.7 and 3.7 and 15.8. So there's 1, 2, 3, 4, 5, 6 observations above Q2. So the median then of these 6 observations is going to be the average of the middle 2 data values, which is going to be the average of these 2. So Q3 is going to be dead center right in here. That's your third quartile. So therefore, your 75th percentile or your third quartile is the average of 17.2 and 18.6.
I have a question.
Oh,
Are you still working on example 4?
oh, I'm sorry. Okay, let me go back over this later because I
Thank you.
get my screen share paused here. So Q2 is the middle value of 3.7 and 15.8 for the whole data set. We found Q2 by taking the average of 3.7 and 15.8, which is by adding those 2 values together, dividing by 2, you get 9.75. That's your second quartile, 9.75. That's literally the middle of your data set. Okay, the lower half of your data has how many observations in it? How many observations are below Q2? Well, that would be the 3.7, the 2.9, the 2.4, the 0, the 0, the 0. So there's 6 observations below Q2. So Q1 is going to be the median of those lower 6 values, the lower half of your data set. So since there's 6 observations below Q2, the first quartile then is going to be the average of the middle 2 data values of the lower 6 data values, which is the average of 0 and 2.4. So to find the first quartile, we take 0 plus 2.4 divided by 2, we get 1.2. That would be your first quartile. How many observations are greater than your second quartile? That'll be 15.8, 16.8, 17.2, 18.6, 19.5, and 76.9. That's 6 observations. Your third quartile, therefore, is going to be the average of the middle 2 of the upper half of your data. That's to say the average of 17.2 and 18.6. And what is the average of those 2 there? Let's see. 17.2 plus 18.6 divided by 2. 17.9 is your third quartile or your 75th percentile. 17.9. So do we understand how we found our quartile values, the 3 quartiles? All right, so that's how you find the 3 quartile values. So you find the second quartile first because that splits the data in half. And then you find the midpoint of the lower half, which is your first quartile, and the midpoint of the upper half, which is your third quartile. That's how you basically do that. All righty. And so this is just re-emphasizing our quartile values. Let's see here. .2% is the first quartile. This third quartile is 17.9%, just like we found there. I want to say got the third quartile is 17.95%. We got 17.9, didn't we? The first quartile is 1.2%. So what does that mean? That means the nations that generate less than 1.2% of the global nuclear power are in the bottom fourth or the bottom 25% of all the other countries. The 50th percentile or the second quartile or the median is 9.75%, which tells us that 50% of the nations get less than 9.75% of their energy from nuclear power. Okay, and the third quartile or 75th percentile is 17.9%. So we would say about 75% of these countries get less than 17.9% of their energy from nuclear power. Okay, and so 25% of the countries get more than 17.9% of their energy from nuclear power. Now a box plot. Once we find the quartile values, we can build a useful plot called a box plot. It's a graphical way of basically illustrating the partitioning of your data set up into those four aforementioned intervals. And in order to compute the box plot, we need to, like I said, compute the first, second, and third quartiles. Now, this is reverting back to the data set that pertained to the test scores. Remember where you scored like 77%? I believe it's that data set there. So the first quartile or the 25th percentile score on that test was it looks like how far apart are these tick marks spaced here? What kind of scaling we got on the horizontal axis here? Well, in between 60 and 70, there's 1, 2, 3, 4, 5. Let's see here, 5 tick marks to go from 60 to 70. And let's see, 2, 4, 6, 8. Well, there's 4 tick marks in between 60 and 70. And so each tick marks represents what? 2. So 62%, 64, 66, 68, and then 70%. 72%, 74%, 76%, 78%, 80%. So these tick marks are spaced by 2 percentage points apart. So the first quartile test score was 68%. So 25% of the exam scores were below 68%. 50% of the exam scores were below 78%. And 75% of the exam scores were below, it looks like about 99%, somewhere in there, about 99%. No, about 89%, excuse me, 89%. The minimum exam score was what? Way down here, about 34%. The maximum exam score projects down to the horizontal axis at a value that looks like about 99%. That was the highest exam score. The interquartile range, which is the difference between the first and the third quartile, basically gives you a snapshot as to the spread that exists between the first and the third quartile values here. All right. Now, just by looking at this box plot, we can ascertain this information very quickly about the data set. because the second quartile appears to lie pretty darn close to being dead center in between the first and the third quartile. In other words, because we have about the same amount of box between the first quartile and the second quartile versus between the second quartile and the third quartile. Ladies and gentlemen, we would say that this data set, for all practical purposes, is symmetric and bell-shaped. In other words, if you were to make a frequency histogram of the middle 50% of your data, we would expect it to be symmetric about the median value. Or we would say this data set is bell-shaped. Bell-shaped, or we would say normally distributed. Okay? So this data set looks like it's a normal data set, meaning it's symmetric and it's bell-shaped. And so we would say that this data set of test scores possesses a rather high degree of normality. And because of that, that's important because that can steer you in the right direction as to what type of test you would conduct on the data if you wanted to conduct inferential statistics. For instance, if you wanted to build a confidence interval or conduct hypothesis testing, you would want to use parametric statistics. If your data set is highly skewed or contains outliers, then you should be using non-parametric statistical analysis on it. Okay. So that does have ramifications. The normality of the data set does have an impact. It does have an impact as to which way we would go with our analysis, our inferential analysis, if we wanted to conduct that on the data set. Furthermore, since the box is rather long between Q1 and Q2, we can see that there's a fair amount of variability with these test scores. Okay. If, ladies and gentlemen, we had a box plot that looked like this, this box is very, very short. That would indicate that there is very little variation between these test scores. We would expect the standard deviation of such a data set to be very small, very small. So you can tell by just the length of the box as to what type of variability you have, or roughly what sort of standard deviation you would have with your data values. So that's the information you can gather very quickly, the normality of your data set, and also roughly, in a rough sense, the standard deviation or amount of variability that your data is exhibiting. Okay. And so the lowest score is 34, the highest score is 99%. So box plots are very useful, and they become even more useful when you're comparing more than one data set. That's when they become very powerful and giving you a very quick picture as to the comparison that exists between the data. All right, and if we were to draw a box plot for the nuclear power data set, where the first quartile is 1.2, the second quartile is 9.75, and the third quartile is 17.9. Notice we lay out a scale from 0 to 80, and these tick marks appear to be spaced by 2 units apart again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, etc., etc. So where would the first quartile go? 1.2. Well, 1.2 is going to be about right here. That'll be the first quartile. Second quartile, which is 9.75, would go about right here. Notice it projects down to the horizontal axis at about 9.75, right in here. Okay. This projects down to about 1.2%, right here, 1.2. The third quartile, which is 17.9, would be right here. That projects down to about 17.9, very, very close to 18. The minimum observation in that power plant data set was 0, and the maximum observation was like a 78, what was it? 2, 4, 6, 8. So like 76 point something. I forget exactly what that raw data value was. It was a 76.8 in that nuclear power plant data set. I think it was something like that. Does it appear that this data set is approximately normally distributed, ladies and gentlemen? You know what, this observation out here, the 76.8, this would probably be classified as being an outlier in the data set. Outlier. It doesn't seem to fit amongst all the other observations. It is much higher than all the other observations. We would call that an outlier. The outlier aside, does it appear this data set is approximately normally distributed? The answer is yes. We have the same amount of box between Q1 and Q2 as opposed to between Q2 and Q3. So this data set appears to be normally distributed and bell-shaped. Okay. That makes sense how we build in a box plot here. So to build a box plot, you need to know your minimum data value, your first quartile, your second quartile, your third quartile, and your maximum data value. That's how you build a box plot. Now, ladies and gentlemen, there is a test to determine whether a data value qualifies as being an outlier. In order to conduct that test, we need to find the interquartile range value first, which is the difference between the third and the first quartile. So 17.9 minus 1.2 is 16.7. Then what we do is we multiply the interquartile range by 1.5, 1.5, which is 25.05. And then any data value that lies below the first quartile minus 1.5 times the interquartile range, which is 25.05, or any data value that's greater than the third quartile plus 1.5 times your interquartile range is classified as being an outlier. So where would be the lower cutoff value for an outlier? It'd be negative 23.85. What's the upper cutoff value for an outlier? 42.95. And so, ladies and gentlemen, that observation, which was about 70, what was it, 76.9? You can see 76.9, okay, is greater than the upper endpoint of the outlier interval, if you will. So this 76.9 is greater than this value. And so therefore, yes, it would be classified as an outlier. Not only would it be classified as an outlier, but in statistics, you would probably discover, and of course in elementary statistics, you would discover that it is an extreme outlier, not just a mild outlier, okay? Because it is way above that upper endpoint value of the outlier interval. Notice we don't have any negative observations in our data set, the smallest one of which was 0. And so we don't have any outliers in the small category, but we do have an outlier in the large category. It's that data point 76.9. And so in order to ascertain whether this data set is symmetric and normally distributed, you would probably be tempted to just throw that data point out of the data set, discard it, because it is an extreme outlier. And if you did do that, then your data set definitely would be normally distributed. But just having one data point, you know, as being an outlier is not really enough to throw your distribution way off from that normal state and throw it into a positively skewed regime. Okay. All right, well, let's go to our book and see what we could do here today. So later on, we're going to we're gonna go to our textbook here. And go to Alex. And these problems will be coming out of 11.5. So we're looking at measures of position today. Okay.
Can you show us a couple before you let us loose?
All right, let's see here. Yeah, let's see. Yeah, we can do all right, let's look at number 8 here, and then I'll probably have you do one similar for class activity here. The heights and inches of 12 students in a seminar course are given as such. And notice these heights, unfortunately, are not they're not sorted. You agree? They're not in order. And so probably the first thing we should do is I want to put these data points in order here. Okay. And so now this data set looks small enough whereby that looks like that's a task that could be done. Unlike most data sets, which number in the thousands or millions of data points, in which case that is so not going to happen. You need a computer system to order your data. All right, but anyways, let's see if we can order this data kind of like together. What would be the smallest observation in our data set? I mean the smallest one.
60.
60. So I'm going to put that on my paper first. Now, I would recommend you might put it like a little slash mark through it so we throw it off the list. What's the next larger one then?
61 and then
61. And then what?
63.
63. And then 64. And then 60 what? 5. And do I have a 66? Yes, we do. 66. You got a 67 here. And we have a 68. 67, 68. Looks like what, 70? 71, 70, what, 2? 70, 71, 72, and we do have a 73. Okay. So it really wasn't that much of a hassle, to order this data. Now in A, they want us to find a percentile rank for the height of 67 inches. So for 67 inches, here's our data ordered. 67 inches lies here. And how many observations are in this data set? There's 12 observations, correct, in the data set. All right, now 67 would be or would have what percentile rank? Well, how many observations are less than 67? That would be 1, 2, 3, 4, 5, 6. And therefore 6/12 times 100% represents what percent? It's going to be 1/2 of 100%, which is to say 50%. So therefore 67 is the 50th percentile. Let's see, 1, 2, 3, 4, 5, 6. So we could call 67 the 50th percentile. Okay. Now 70 inches would be right here. We have 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8. So 8 observations are less than 70. So that would be 8/12 of 100% for a percentile value. And that's going to take this down to 2/3 times 100%, which is going to be about 66.666666666%. Do you agree? So you might want to bump this up and call it about the 67th percentile. 70 is the 67th percentile. Is that making sense how we're computing these percentile ranks for these data values once our data set is ordered here? All right, and so, like I said, if you ever get a decimal for the percentile rank, just round it off to the nearest whole number, the nearest whole percent. And let me know, like, if there's any issue with, like, Alex, if he complains about, especially if you have one that has like a 0.5, that could be an issue because it was not made clear at all in our textbook as to how to deal with one that has a 0.5 percentile value, whether we rank it, round it down or round it up to the next whole number. And I'm not 100% sure, ladies, on how Alex would deal with that. I don't think you're going to have that situation, but if you do, and if your problem's marked wrong, all you got to do is just bring it to my attention. I'll go take a look at it. Okay. All right. So let's see if you can do problem number 7. Call this classwork number 1. I want you to take these math test scores and put them in order, first of all. And then I would like you to determine, to the best of your ability, the percentile ranks of these various scores here. Okay, so let's go ahead and see if we can do that problem. We'll call that classwork number 1. All right, ladies and gentlemen, I'm going to take a look at these here. So there were 20 50-point math test scores here. And they want us to, compute the percentile rank for each of these scores here. Did anybody get the percentile rank for a score of 32? Just curious.
Twenty percentile?
Okay, that sounds good. How about for a score of 44? Anybody get that percentile rank? If you scored 44 on this exam, where are you in the percentile rank?
I got 70 percentile.
70th percentile? Did anybody get anything different? For 44, 70th percentile. Let me see. Let me double check this here. And that's for 44, right? Okay, hold on a second here. Oh, let's see. How many observations are less than 44? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 observations. And let's see, 14 divided by what? 20, right? 14 divided by 20. '70th percentile. That's what you got, right? 70th percentile. All right. Good. How about 36? What percentile does that fall in? 36. Anybody? Anybody compute the percentile rank for 36?
Thirty-fifth percentile.
All right, that sounds pretty good. All right, how about 27? Where's that? 27. So if you score a 27 out of 50 here, is that a good score or a poor score? What do you think? What percentile is 27?
Of 0.05.
Okay, so if you multiply that by 100%, that'd be what, 5%? The 5th percentile? So what do you think? That means only 5% of the scores are lower than your score, and 95% of the scores are higher than your score. That's not really too good, is it? 5th percentile is not very great. All right, how about 49? If you score 49 out of 50, what percentile do we find ourselves in? Did anybody get 90%?
I got 85th percentile.
85th percentile. Okay. 85th percentile. All right. You know, what I find amazing in the field of statistics, ladies and gentlemen, is that this is true too. There is no universal way to compute percentile values. In other words, if you compute percentile values using your TI-84 calculator, they might be a little bit different than if you used Excel spreadsheet. Or they would be a little bit different if you use like maybe a statistical software package, like maybe Minitab or Systat or something like that, or SAS. So there is no universal way of computing percentiles. One stats book will show you one way. Another stats book will show you a slightly different way. Another stats book will show you an entirely different way. You would have thought after all these years, statisticians would have sat down and universalized how percentiles are to be computed, but they've never done that. They've never done that. And because of that, ladies and gentlemen, on Alex, if you feel like your percentile computation, your percentile rank computation is correct, if Alex squawks about it. Now, Alex should allow a little latitude. They really should, because of the non-universality of how these things are computed. But if it squawks about it, just let me know, and I'll take a look at it, and I'll see if it's within reason. And if it is, I'll give you the points back. Okay, so keep that in mind about percentile values. All right. Okay, let's look at a different problem here now. I am going to do problem number 10. Number 10. It says, in a class of 400 students, John's rank was 80. Find the percentile rank. Now, be careful, ladies and gentlemen. To say John's rank is 80 is not saying the 80th percentile necessarily. A percentile rank is not necessarily the same as the rank. Okay, be careful. Now, if John ranked 80 out of how many students? 400. How are we going to compute John's percentile rank? Well, let me ask you this. How many students were ranked below John? How would you determine that? The number of students ranked below John.
400 take away 80.
400 minus 80, which would be 320 students. Do you agree? So 320 students were ranked below John. So here's what we have to do here. We're going to take 320, which again was found by taking 400 minus 80. And we're going to divide that by 400. And then we're going to multiply this by 100%. So get on your calculator, ladies and gentlemen, dial this up. You tell me what percentile rank is John's rank of 80 out of a class of 400. What's the percentile rank? Let me know if anybody gets it. What percentile rank is this? This is the what percentile? To be ranked.
80th?
Yes, the 80th percentile. Now, is it just a coincidence that being ranked 80 out of 400 turns out to be the 80th percentile? The answer is yes. It's purely coincidental in this case. Don't think for a moment that the rank is always equal to the percentile rank. It may or may not be. If it is, it's purely coincidental. Okay? So be careful on that one. All right, ladies and gentlemen, I want you to do number 11 now. We'll throw that into classwork number 1. In a charity marathon to raise money for AIDS research, Chen finished 43rd out of 200 entrants. Find the percentile rank. Oh, careful. Don't just say it's the 43rd percentile. Not necessarily. Actually compute it the way I did above. Go ahead and do number 11. What percentile rank is finishing 43 out of 200 entrants? So if you finish 43rd out of 200 entrants, that means how many finished below you? That'd be 200 minus 43, which I believe is 157 entrants finished below you. Therefore, what percentile rank is finishing 43? Well, it'd be 157 that finished below you, divided by the total number of entrants, which is 200, times 100%. And what percentile rank does that give us here?
39.
39th percentile. All right, the 39th percentile. Wait a minute, 39th percent, is that right?
It's 78%.
I got 78 point, yeah, 5, but I don't know what you do with the 5.
Yeah, okay, no, 78.5. You know what your author did? They bumped it up to the 79th percentile. So ladies and gentlemen, they call this the 79th percentile, which means that 79% of all the entrants finished below you or later than you, if this is a race, okay? We'll call it the 79th percentile. All right, good on that one. All right, now the next one. Number 14. This one we can just do as a class. So this is not a class, number 14. Out of 600 applicants to a graduate program at an Ivy League school, Marissa's GRE score was in the 25th percentile. How many applicants scored lower than Marissa? How would you do that problem? How would we determine how many people scored lower than Marissa's score? First score is a 25th percentile. How would we figure out how many people scored lower than her score? Well, how many people took this exam? There were 600. And of 600, 25% must have scored what? Lower. Do you agree? So Liz, we got to take 25% of 600, which is going to be 0.25 times 600. And what's that going to be? Is that 150? I believe it is. So 150 applicants scored lower than your score. Make sense? That's to say you're in a 25th percentile. All right, now you do this for classwork number 2, number 15. Eldrick finished at the 77th percentile of men's golf league with 88 players in it. How many golfers finished above him? Careful, how many golfers finished above him? Go ahead and do that for classwork 2. All right, so if you finish in the 77th percentile, that means 77% of the golfers finished with a score worse than yours. And that means what percent finished above you then? Would that be about what, 23% finished above you? So of the 88 players, 23% finished above you. So what's 23% of 88? That's 0.23 times 88. So 23% of the golfers must have finished above you. So 0.23 times 88 gives you about how many golfers? About, say about what? Anybody get 20? Approximately.
Yes.
Of 20 golfers had scores better than your score. Just see what the author said here. 19.
So how did they decide that it was gonna be a 19?
No. All I know is I got 20. Okay. So like I said, ladies and gentlemen, Alex, if your problem gets marked wrong and you're pretty close, just let me know about it and I'll look at it. Okay. Because there is no universal way of computing percentile values again. And so there might be a little bit of a discrepancy in there. All right. 20, close. You got to admit, pretty close to 19. All right. All right, let's look at another problem. Another one. All right, number 18 is an interesting problem. I'll kind of work through this one here. Number 18 says, in an English class of 30 students, Audrelia's percentile rank is 20. That's her percentile rank. So she finished in the 20th percentile. Miranda's class rank, however, is 20. Notice class rank is not necessarily the same as percentile rank. You got to be careful here. Whose rank is higher? Well, we know Audralia finished in the 20th percentile. We need to compute Miranda's percentile rank. How would I compute Miranda's percentile rank? This is just her class rank. That's not her percentile rank. Anybody help me out to compute Miranda's percentile rank? How do we do that? Her class rank's 20. How many students were in her class? How many students totally are in the class?
30.
So how many finished below Miranda? 30 minus 20, or 10 students finished below her. And because 10 students finished below her, we can now compute her percentile rank. It's going to be 10 divided by 30 times 100%. That's going to be Miranda's percentile rank. So what is 10/30 times 100%? Well, 10/30 is reduced down to 1/3. 1/3 is a decimal, is 0.33333333333333333 repeating decimal. So what is that repeating decimal? 0.3 forever times 100. That's about 33%. About 33%. We'll call her percentile rank about 33%. So who had this is the 33rd percentile, we should call it. About the 33rd percentile. So who had the larger percentile rank? Audralia or Miranda?
Miranda.
Miranda did. 33rd percentile is higher than the 20th percentile. Notice Miranda has the higher rank. Okay. So be careful on that one. All right, that's one like that. Now, number 19 is a beauty. It says the University of Wisconsin men's basketball team finished the 2020 season ranked 28th out of 358 teams, while its football team was ranked 13th out of 130 teams. Which team had a better ranking? All right, here's what you got to do, ladies and gentlemen. I'm going to give you a hint. You have to convert this 28th ranking into a percentile rank for the basketball team. And then you have to convert this 13th ranking into a percentile rank for the football team. And then just compare the percentile ranks to determine which team had a better year. Go ahead and do that. We'll call that classwork number whatever. It's a classwork. Number 19. All right, which one had the better year, football or basketball team? Anybody? Anybody?
Basketball.
You said the what team?
The basketball team.
Basketball team, okay. Yeah, I think you got it. Notice, finishing 28 out of 358 teams. Means that 330 teams finished below you out of 358. That puts you in the 92nd percentile bracket. Football, 13, you were ranked 13 out of 130. That means 117 teams finished worse than you. That puts you in the 90th percentile. You are correct. The basketball team eked out the better season. 92nd percentile versus 90th percentile. There you go. All right, let's see what else we got here. All right. Okay, ladies and gentlemen, I'm gonna have you build a box plot here, if I could. The problem will be number 25. What I want you to do with number 25 down here is I want you to compute the quartile values, the first, second, and third quartile values, and then build a box plot. This data set pertains to the average cost of a 1-hour massage in 10 large cities. Is the data ordered or sorted? No. First thing you got to do is order your data set, ladies and gentlemen. Go ahead and do that. Find the first, second, and third quartile. Build a box plot. Number 25. This will be the last problem today. All right, now this is the box plot I constructed now. First of all, I sorted the data, smallest to largest, left to right on my paper. 10 observations. Therefore, the median or the second quartile or the 50th percentile is going to be the average of the two middle data values, 88, 89, gives you 88.5. There's 1, 2, 3, 4, 5 data points in the lower half and 5 data points in the upper half. The middle value of the lower 5 data points is going to be 78 because there's 2 observations to the left, 2 to the right. That'll be your first quartile, 78. Third quartile is going to be the middle of the upper 5 data values, which is going to be 93, 2 to the left, 2 to the right. You can build your box plot. I scaled my horizontal axis, spacing tick marks 10 units apart. And you can see that Q1 projects down to about 78. Q2 is about 88.5. Q3 is about 93. And there you go. Looks like you have a little bit more box between Q1 and Q2 as opposed to Q2, Q3. Because of that, we would say this data set is approximately, it's a little bit skewed to the left, skewed in a negative direction. So a frequency histogram for this thing would probably look like something like this. So this data set is a little bit skewed to the left, okay? Skewed a little bit to the left. And there you go. All right. Did anybody come up with anything similar?
Yeah, that's pretty much what I got.
Pretty close. Okay, that's good. All right, ladies and gentlemen, so we looked at measures of position today. Percentiles, quartiles, building a box plot. And just keep in mind with these percentiles that they are not universally computed again. So if there's any little discrepancy, like on Alex, you feel that you were close, just let me know. Give me a heads up. I'll go take a look at it. And, I'll allow a little wiggle room if Alex does not. Okay? All right, I'll stay on the line for a couple minutes if you have any questions or comments. Otherwise, have a great day, and hopefully I'll see you in a couple of days.
So when would you upload the homework for this section?
I'm gonna try to do that ASAP, okay? As soon as possible.
Okay,
All
okay.
righty.
all right.
Have a nice day.
So I would like to know, when will you upload like these videos? Because I would like to be able to go back and watch it.
Yeah, that's also something I have to tackle this evening, okay? Try to get updated with these videos, all right?
Okay, and then I have one more question. So on the last quiz, I scored a 90 first, right? And I missed 4 problems. So I reworked those problems, and I then still got all of those problems right. I mean, wrong, and missed something. I know I'll still get the 90%. That's not my issue. My issue is I don't know what I did wrong, and I don't know, and I won't be able to, it's closed, so I can't check it to even try to figure it out, just in case I see those problems again.
Were they all pretty much similar problems to each other or not? Or were they all different?
They were different.
All different.
Yeah, but it was 4 of them. I redid it, and I ended up getting 89 the second time, and I'm like, what?
All right.
So here you go. If you want to relook at it, you just have to go all the way down to the quiz and then look at hit the percent and then see what ones you got wrong and then go back and look at it. Because that's what I do when I go through the wrong ones.
So you click on what now? The percent? You click on a percent.
The percent of the score that you got.
Okay.
Okay.
You hearing that? Click on a
Yes.
percent of the score you got, and it what enables you to go back and look at it, or
Yeah.
okay.
Oh, thank you.
All
Yeah.
right. Yeah, thanks a lot. All right.
And then I also have a question because number 5 on the quiz, because I had to redo it too, and it was the pie chart.
Uh-huh.
And all the numbers, it wasn't even at 100, it was at a 103.
Okay.
So like I got the percents right technically, but at the same time, like Alex is saying that I got it wrong because I didn't put 3 of them down by 1.
Okay, so what is your last name?
Fick, Fick.
All right, what quiz was that?
The chapter 11.
The chapter 11 quiz. And the problem was number what? Number 5?
Yeah.
Okay. All right, I'll go back. I'll take a look at that. Okay.
All right. Thank you.
Yep.
And when will you open up? So will you open up this next Tuesday? I'm talking about like the quiz and the test, or will you open it up this week?
You mean the remaining thing that we have to do?
Yes. Would it be like this Thursday, or
You mean like 11, 5, 11, 7, and chapter 11 exam?
yeah, would it be this Thursday, or would it be like Tuesday of next week, or?
Well, let's see. We done 11.5. See, I still got to do 11.6 and 11.7 though. That's the thing, you know,
Mhm.
that's on there. So I mean, even if I open it up early, you would have to take it upon yourself to go over 11.6, 11.7 all on your own. You know what I'm saying?
Yeah, and I don't want to do that. I just wanted to know like what would be the date that you
Yeah,
probably.
it will be the 19th, December 19th, you know.
Okay. All right. So we'll have a day. We'll have 2 days basically to do it. Okay.
Um,
Well, the
yeah,
19th is what did we say? The 19th is a Wednesday?
it's a Tuesday.
It's a Tuesday? Okay.
That's the last day of class, next Tuesday,
Okay.
1 week from today. Okay.
Okay.
All right.
Thank you.
All right. Have a good day.
You too.